So today in this video, we're going to be continuing our quest towards asking more about angles because the angles in trig are always considered the domain. And we're going to be learning what is a radian and why do I care what it is. But before we even think about what a radian is, I want to ask, what are units of measure used for angles that you're familiar with? Now, some of you might be saying, well, based on the past few videos, I know that degrees is for sure a unit of measure for angles. And degrees is always notated by a little dot on top of the number. And what's important is for a word problem or anything in trig, if you put an answer of 45, your teacher might say, what do you mean? 45 inches, 45 miles, 45 centimeters? So if you do not have this symbol, we don't know that you're talking about an angle. So please be careful about that. A lot of you probably said degrees and then are at a loss for saying, what else can I do to measure an angle? Well, there's another type that I'm going to inform you about called degrees, minutes, seconds. Now, degrees, minutes, seconds is another way to measure an angle, and it is something that is that uses base 60. Now, some of you might be saying, what does base 60 mean? Well, first, let me define something called base 10. Everything you've been using in mathematics so far has been in base 10. For instance, think about scientific notation. You could put a number like 3.1 times 10 to the fourth. So that is base 10. Think about the definition of a percent. Percent means out of 100, which is a multiple of 10. So a lot of things you've been doing have been used in the base 10 system. Mathematicians also have something called the base 60 system, which sort of makes sense because if you're doing minutes and seconds, you have your conversions that 1 minute is equal to 60 seconds, and you also have, oddly enough, that 1 degree is equivalent to 60 minutes, which we'll use those conversions right now, actually. So let me give you a number that's in degrees, minutes, seconds. 50 degrees, 25 minutes, 10 seconds. This number probably means nothing to any of you yet. So let's consider taking it and converting it into degrees. To do that, we would take the 10 seconds here, and we would divide that by 60 because it takes more seconds in the same time period as a minute. So we'd take 10 divided by 60, and we would get this ratio to be 0.16. And now we've converted the seconds to minutes. So far, we would still have 50 degrees, but now we have 25.16 minutes. Because of this conversion rate, if we wanted to change these minutes, 25.16, to 50 degrees, we would take the 25.16, divide that by 60 as well, leave the 50 alone because we're going to convert this to degrees. 25.16 divided by 60 ends up getting you 0.419. So now these are in degrees. So my answer in degrees would be 50.419 degrees. Now, some of you might be saying, wow, do we have to do that? Why did you show us that? Well, the reason I wanted to show you that was to transition into what a radian is. I have good news. Degrees has to have some kind of label, some kind of unit. Degrees, minutes, seconds definitely had some kind of units. A radian, there are no units in the way. So when you're measuring something or an angle in trig in radians, you never have to deal with a unit. So if you ever see a number like 2 without a unit, you assume it's in radians. And that, guys, is why a radian is so useful, because you don't have to deal with something like degrees, minutes, seconds. So let me define in terms of a picture what a radian is. There's a definition above that I grabbed from your packet. The definition of 1 radian is the measure of a central angle, so here, whose sides intercept or cross an arc, here, equal in length to the radius. So what a radian really is a ratio of the arc length to the radius, because A radian is defined is that when your arc length is the same length as your radius. So if I wanted to write that as a little formula, your angle in radians would be equal to the ratio of the arc length, which we symbolize with S, and the radius, which we symbolize with R. So this is going to come back into play in a little bit. So please be aware that it is a ratio. It is an angle, and it's a ratio of the arc length to the radius. And just to prove my point, let's say that the radius and the arc length were both in inches. The reason that a radian has no unit is because if you did the arc length is S inches and the radius is R inches, the inches would cross out in your ratio. Now, it's a really good idea to consider what does a radian look like and how many radians are in a full circle. So this picture here, this little piece is 1 radian. That is exactly how big it is. So on this other circle here, what I decided to do was copy this little picture, and I'm going to drag them to see how many radians are in a full circle. So let me take this piece, put it in right next to here, this piece. So far we have 3 radians fitting in a circle. Easier said than done. So it's not perfect, but it looks to me that if we were looking at this picture, that we had 6 radians, 1, 2, 3, 4, 5, 6 fit in, but then we have this little area here that is not a full radian. So I would say right now we have about 6 radians in one circle rotation or revelation. But it's good to ask yourself, okay, if I'm going around the circle once, it's about 6 radians, but some of you might be saying, Mrs. Logus, exactly how many radians is it? I absolutely have to know. Don't worry, guys, I got your back. Let's go to the next slide and figure out exactly how many radians we have. So we think it's about 6, but we need to make sure. So let me write down that little formula for a radian, that a radian is really same as the ratio of the arc length over the radius. And remember, there are no units. In order to truly figure out how many radians we have, let's consider a full circle. And some of you might remember that arc length, S, represents the perimeter of the circle. Because if you picture drawing a circle, circumference, or the perimeter, represents your distance all the way around the circle. And some of you also might remember from geometry that circumference is symbolized by 2 pi r. So if we're considering a full circle or going all the way around a circle, we can replace the arc length or a portion of the perimeter with 2 pi r. Then we can divide that by r, because that's here. If we cross out the r's, we have theta equals 2 pi, which means that my angle all the way around the circle, it takes 2 pi radians to get all the way around. So again, if I start here, go all the way around the circle, that as a length is 2 pi. And if we take 2 times pi, or 2 times 3.14, on and on and on in the calculator, we get that to be about 6.28. So we have 6.28 radians all the way around the circle, and that is going to help us on the next slide as well. So keeping this number in mind would be a great idea. It'll help us with examples like this that you might recognize from the last video. Draw or approximate the following angle of 4. So this is what I mean. You're like, angle? This doesn't have any units. Right. So if 4 doesn't have units, you consider that it is in radians. So we just figured out on the last slide that when you go all the way around the circle, that is about 6.28 radians. And I'm just writing radians here. I'll write it in parentheses so you know what I'm talking about, but remember that 6.28 doesn't really have a unit. So I have 4 equal quadrants And I know that there's 6.28 radians all the way around this coordinate plane, or this circle, which means that if I take 6.28 and I divide that by the 4 equal quadrants, I get 1.57, which means, kind of like degrees, I can walk my way around the unit circle here. I can say this would be 0, this would be 1.57. If I add 1.57 to 1.57, I get 3.14. Interesting, that might remind you of pi. If I add 1.57 to 3.14, I get 4.71. And so if I ask you, draw or approximate the following angle of 4, what you could do is say, let me start here. Let me draw my terminal, or my vertex and my terminal side, like the last video. If I want to draw an angle of 4, look like I'm going all the way around and getting close, because we have 4.71. So I'd say that we end right about here. And this in purple, let me grab purple, this would be my theta in radians of 4. If we looked at the next example, notice that the angle is negative 2.5. So if I go back to labeling my picture, we are going to go the other direction. So if I have 0, this would be negative 1.57. So this would be negative 3.14, and then negative 4.71. So if I were to, again, draw my angle, I would start vertex, initial side. I would go this direction this time, past 1.57, and 2.5 would probably be somewhere in the third quadrant. So this would represent my angle in radians, so theta would equal negative 2.5 radians. So that is really useful. So you're going to be able to both understand that on a coordinate axis you can graph both angles in radians and degrees, and they're somewhat of the same method. Given an arc length of 25 degrees and a radius of 17, find the central angle in radians. Well, I know that a radian is defined, so theta is in radians. Radians is defined as the ratio of S over R, or again, arc length over the radius. So if I said that theta is really equal to the arc length, which the problem told you was 25 feet, over the radius, which told you was 17 feet. Again, hurrah, the units cross out, so we know for sure it's a radian. And so we could probably leave our answer as 25/17 if we'd like to. So theta is 25/17, and you don't even need a unit, but that would be our angle. If you wanted to, you also could approximate that as a decimal. So if you have your calculator out, if you took 25 divided by 17, you would get 1.47 radians. Last but not least, it's good to ask ourselves, which is bigger, 1 radian or 1 degree? Well, if we think about it, to go all the way around a circle, it takes 360 degrees to go around one circle. And then if we think radians, we learned earlier that it takes about 6.28 radians to get around one circle. So what I'd like you to do for a second is pause the video and ask yourself, which one do I think is bigger based on this information? Well, I'm interested in what you thought. Do you think that a radian is larger, or do you think that a degree is larger? Well, in the end, I came to the conclusion that a radian is larger because if you think about it, it takes 360 degrees to get around one circle, but it only takes 6.28 radians. So that means that these are way larger than a degree. What I have here, I don't have time to go to it right now, but I have a link that you might be interested to go to that shows an image of what a radian is. So kind of if I go back to the slide where I dragged, yes, this right here where I said there was about 6 radians, there is a nice little video there that might help you understand what a radian is as well. So I thought that would be a good resource. All right, guys, thank you, and good luck with radians.